Hello everyone, welcome back to my Additional Maths channel. For today's video teaching, I will share with you how to master the skills of doing the limit. Many of you you don't understand how to solve the limit because you don't understand the concept. So today I will share with you the good video teaching on doing and solving the limit. So I really hope that you will follow the video teaching and make sure you really understand what is actually the limit and how to solve the limit. Alright, so it is not easy because it's behind the limit. It actually involves many hidden concepts. So for calculus course, actually we will start with the concept. So for my first video, I actually share with you one of the very outstanding video on explaining the concept of the calculus. So actually that concept is not easy to explain or not easy to teach and not easy to understand. So I guess many of you actually wonder what is actually calculus and what is differentiation. So you may actually go through the video many times until you master the concept. Then for the second video, we will actually focus on the limit, and for the third video we will do the basic skills of differentiation, and for the next video maybe we'll discuss application of the differentiation after you master all the differentiation skills. Alright, so for Form 4 students, you have this topic in your Form 5 syllabus under KSSM. So this is a tough and challenging topic. So I will actually prefer you to start right now. Alright, so maybe I will share with you the exercise for doing the calculation for differentiation and the skills of doing differentiation. Alright, so it's better for you to start early than next year, because next year you will be burdened by many subjects and many homework. So for you to do well in additional maths, actually you're supposed to start right now and try to pick up all the skills, okay, until you are expert. Then come to next year, you will be actually a bit relaxed when come to additional maths, and you will feel less burden to face the exam next year. Alright, so I really hope that you will focus to the video teaching and learn from the teacher who are very good and they willing to share their knowledge with us. So I would like to take the opportunity to thank the Max Pop again for willing to share with me the good quality video teaching on additional maths. Okay, let's get started with the video teaching now. Have fun.
G of x is defined as 3 pieces. So whenever I'm dealing with a piecewise function, I like to redefine the function on the x-axis. Now, first piece. For x less than -1, so I'm going to label -1. So for x less than -1, that means on the left side of -1, g of x is defined as 2 minus x. So g of x is defined as 2 minus x. Cool. Next. for x between -1 and 4. So between -1 and 4, g of x is defined as 3x squared. G of x is defined as 3x squared. And lastly, for x greater than 4, that means on the right side of 4, g of x is defined as the square root of x. So g of x is defined as the square root of x. Now, take a look at this diagram. See, by redefining the function on the x-axis, it's a lot easier to see that the function is being broken down to 3 pieces. And on the left side of -1, the function is defined as 2 minus x. Between -1 and 4, the function is defined as 3x squared. And then on the right side of 4, the function is defined as the square root of x. So now we are ready to evaluate the limit. Look. First, we want to find the limit of a function as x approaches -1. Approaches -1. From which direction? Negative notation means from the left, right? From the negative direction, from the left. So on the left side of -1, the function is defined as 2 minus x. Yeah, so guess what? On the left side of -1, we can replace the function with 2 minus x. See that? Just like that. Cool. Now, to evaluate this limit, easy. Let's apply direct substitution. So, let's directly substitute the x value, -1, into the function. Okay, so we have 2 minus x is just -1, right? Direct substitution. So the answer is equal to 2 minus negative becomes plus, right? So 2 plus 1 is equal to 3. Okay, so the left-hand limit, as x approaches -1 from the left, the limit is equal to 3. Okay, now, next. We want to find the limit of a function as x approaches -1 from the right. Oops. Let me use this color. Right. Because positive notation means approaching from the positive direction, means approaching from the right. Okay, so approaching -1 from the right. Well, look. Here's -1. On the right side of -1, see, approaching -1 from the right, the function is defined as 3x squared, right? Yeah. So on the right side of -1, the function can be replaced by 3x squared. Okay? Yeah. Now, to evaluate this limit, easy. Apply direct substitution. Direct substitution, right? So let's directly substitute the x value -1 into the function. So 3x squared, and x can be just substitute x with -1, right? -1. Okay? So -1 squared is equal to 1. And 1 times 3 is 3. Next. Next, we want to evaluate the limit of a function as x approaches -1 from both directions. Well, we know this limit only exists if the left limit is equal to the right limit. And that is the case right here. See, left limit is equal to 3. Right limit is equal to 3. That means the limit as x approaches -1 from both directions exists and has a value of 3. And we're done. Cool. Next. So here we want to evaluate the limit of function as x approaches 4 from the left. Okay? So now, approaching 4 from the left, the function is defined as 3x squared, right? Yeah. So approaching 4 from the left, the function is defined as 3x squared. Now to evaluate this limit, let's apply direct substitution. Direct substitution. Okay, let's go. So directly substitute the x value 4 into the function. So x right here is just 4. Okay? Yeah. Now, so 4 squared is equal to 16 times 3, we have 48. Okay? Next. We want to evaluate the limit of function as x approaches 4 from the right. Okay? 4 from the right. The function g of x is defined as the square root of x. Right? So the function g of x is defined as the square. So the function g of x is defined as the square root of x. Okay, guys, by the way, I made a typo there. The function should just all be g of x, not f of x, because in this case, the function is a g function, right? Not an f function. So just ignore the g. Just ignore the f, okay? So this is all g. So g of x, 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 and g of x. So anyways, yeah, so on the right side of 4, the function g of x is defined as the square root of x, right? Now, to evaluate this limit, apply direct substitution. So directly substitute 4 into the function. Then we have the square root of x is just 4. Okay? And square root of 4 is 2. Now, finally, we are considering the limit of the function g of x as x approaches 4 from both directions. And we know this limit only exists if the left limit and the right limit have the same value. And in this case, the left limit and the right limit, the values don't agree. And therefore, we say that this limit does not exist. D and E. Find the limit of the function 5x squared minus 20x plus 17 as x approaches 3 from both directions, right? Because, guys, look, if the direction is not specified, that means we have to consider approaching the value from both directions. Now, I know you all can't wait to apply direct substitution to evaluate this limit. However, you have to be careful, because we can only apply direct substitution if the function is continuous at the x value that we are interested in. So you always gotta ask yourself, is this function continuous at this x value? Because if it is, sure, let's go ahead and apply direct substitution, right? If it's not, then then we gotta evaluate the limit some other ways, right? Yeah. So in this case, here we have a polynomial function. And we know that polynomial functions are always continuous everywhere. And therefore, whenever we see a polynomial function, that's good news. That means we can always apply direct substitution, right, to evaluate a limit. Okay, so that's it. So in this case, we simply have to directly substitute the x value 3 into the function. Okay, so the function is 5x squared minus 20x plus 17. Right? Now, for all the x's in the function, we're just gonna directly substitute them with the value 3. Okay? That's it. So here we have 3 squared is 9. 9 times 5, 45. Minus 20 times 3, that's 60. Plus 17. Right? So 45 minus 60, that's negative 15. Plus 17, we get 2. Okay? So the limit of this function as x approaches 3 is equal to 2. Evaluate the limit of this rational function as x approaches negative 2. Now, before we apply direct substitution, we always got to make sure one thing. That is, the function must be continuous at the x value we are interested in. So in this case, the function is a rational function. Now, for a rational function, we know that denominator cannot be 0. Right? So the denominator, 5 minus 4x, cannot be 0. So solve this inequality. Negative 4x cannot be negative 5. So divide by negative 4 on both sides. So we have x cannot be equal to negative cancels out 5 over 4. So this tells us this function, this rational function, has one discontinuity, which is at 5 over 4. Right? Because the function is not defined at this x value. So in other words, other than 5 over 4, the function is continuous everywhere, right? Because this is the only discontinuity this rational function has. So that means outside of this discontinuity at 5 over 4, the function is continuous everywhere, which means at x equals negative 2, the function must be continuous. And we can apply direct substitution to evaluate this limit. Okay, cool. So let's apply direct substitution. So the rational function is x cubed plus 3x squared minus 1 over 5 minus 4x. Right? Now, in the place for all the x's, what do? We directly substitute the x value negative 2 into all the x's, right? Yeah, so x right here, substitute negative 2. X right here, substitute negative 2. X right here, substitute negative 2. Right? Yeah, direct substitution, easy. Now we just have to clean up the algebra, okay? So negative 2 cubed is negative 8. Plus, now negative 2 squared is positive 4. 4 times 3 is 12. And then minus 1. On the bottom, we have 5 minus, so 5 minus who? 4 times negative 2 is negative 8, right? Now, negative, they become plus, right? Yeah, okay? So that's it. So up at the numerator, we have negative 8 plus 12, that's 4, minus 1, we have 3. So at the denominator, we have 5 plus 8, that is equal to 13. So the limit of this rational function as x approaches negative 2 is equal to 3 over 13. Let's determine the limit of a function which is 0, right? Yeah. So, so we can evaluate this limit by using direct substitution, or we can also evaluate this limit by using the graph to help us sort of visualize what's going on here, right? So approaching from the left, approaching from the right, the function approaches the same value, which is the value 0. Okay? Yeah. Let's determine the limit of a function, absolute value of x, as x approaches 0. Before you apply direct substitution, we always gotta ask ourselves, is the function continuous at 0? Well, let's analyze this absolute value function. First of all, the function x itself is a polynomial function, right? Because this is a polynomial function of degree 1. And the polynomial function is always continuous everywhere, as we discussed earlier, right? Now, if we take the absolute value of a continuous function, then the absolute value function must also be continuous. Yeah, so the absolute value, the function absolute value of x is continuous everywhere. Because if you take the absolute value of a function that's continuous everywhere, then the absolute value function must also be continuous everywhere. Which means the absolute value of x must be continuous at 0, right? Because it's continuous everywhere. Now, that means, well, if the function is continuous at the x value we are interested in, that means we can apply direct substitution to evaluate the limit, right? Yeah, simple as that. So let's apply direct substitution, right? And then we simply directly substitute the x value 0 into the function, right? So x right here, just substitute it with 0. And absolute value of 0 is equal to 0. And we're done, right? And guess what? We can also visualize this on the graph. Now the graph of the function absolute value of x, it looks like this, right? Now, so the limit of the function absolute value of x, as x approaches 0 from both directions, right? Because if remember, if the direction is not specified, that means we have to consider approaching the number from both sides, right? So approaching 0 from the left, approaching 0 from the right, the function, approaching from both directions, the function approaches the same value, which is 0, right? Yeah. So, yeah. So we can evaluate this limit by using direct substitution, or we can also evaluate this limit by using the graph to help us sort of visualize what's going on here, right? So approaching from the left, approaching from the right, the function approaches the same value, which is the value 0. Okay? Yeah.
Okay, thank you so much, Sifu, for sharing such a good lesson on limit and the concept behind the limit. Thank you once again. Till then, I shall see you all in my next video sharing. Bye bye and have a nice day.